So we are going to look into how we can use interrupts in FreeRTOS. You should be familiar with the idea of interrupts, what interrupts are and how we use interrupts, how the CPU behaves when an interrupt signal occurs, and what is an ISR, the interrupt service routine. So there can be many different sources of an interrupt, like it can be from a timer or it can be from data received over an UART. In my example here, for my demonstration purpose, I'm going to use the interrupt that is generated by pressing a button. So I will have my board configured, and I will configure the pin that is connected to that button to generate an interrupt signal. Just for your information, the board that I'm using is it uses a Cortex M4 processor, and the microcontroller is an STM32F446. So let me go ahead and let me paste in the code to initialize the button. So I have my function here, so button initialized. You don't need to understand what I'm doing inside this, because this is just for configuring that button. So your interrupt might be from a timer or from something else, so that is going to have a different configuration, but I need to call it inside my main, of course. So I'm initializing the button. So right now, if I press the button, if I execute this code as of now, and if I press the button, then the CPU will jump to an ISR. So it will start looking for the ISR that corresponds to this interrupt, the interrupt generated from this pin where the button is connected to. And I've checked the data sheet, and I found out that the interrupt that this pin uses is this one. So basically, this is my ISR, my interrupt service routine. This is right in here, my ISR. So every time I press the button, then the CPU jumps here and it starts executing any code that I have inside this function. And let's go ahead and let's write something inside, like printf. Hey, you press the button. So I have my statement here. So every time I press this button, it is going to print on the screen, hey, you press the button. But the idea of interrupt is to keep it as short as possible. You do not want to keep the interrupt long, or you do not want to have any blocking code inside the interrupt, because the scheduler itself is it is relying on a timer interrupt. So if you want to have some blocking code inside the interrupt, then this is going to cause some problems servicing the other tasks. So the idea is short, the idea is simple, that you need to keep your interrupts as short as possible. In FreeRTOS, you don't actually write anything inside the ISR itself. You don't write any code that you want to execute inside the ISR. So what I want to do is I want to print this statement, but I'm not going to do it inside the ISR. But instead, I will create another task for this interrupt. So let's go ahead and let's do that. I'll call it task handle underscore t, my interrupt task handle, and initialize the null value. And I will also create another task, and I will call it my int task. And I need to have an infinite loop inside, of course. And this code that I have written here, it needs to be inside the infinite loop of this new task that I have created. And in my main, of course, I need to declare the task. So it's going to be my int task. I will call it my int task, and the handler is going to be my int task handle. Okay, so I have created my new task, but now what the problem is going to be if I run this as of now is when the scheduler starts, then it will start running these tasks one by one. So it will go to task 1 and it will print hello world, and then it will go to this new task that I have created, and it will print hey, you press the button. I have not pressed the button, but still it will keep printing hey, you press the button. So what I need to do is I want to suspend this task. I don't want it to execute anything. So btask suspend. Again, if you recall from the previous video, where I'm talking about vTosk suspend. If you use a null value, it means that the task will suspend itself. So let me make a small note here. Task will suspend itself, and anything after this won't be executed unless resume from ISR. So it basically means it will come here and execute this line of code, that's vTosk suspend, and then this task will be blocked. It will not continue and it will not print the next statement. And if I want to resume it, that will be done from the ISR. So every time I get an interrupt signal, it will move to this ISR and then it will resume this task here, and the code that you have, it will start executing those as well. But in my ISR, I don't use this function called vTosk resume, but instead I need to use a function called yielding. So it's called port yield from ISR. But before that, I need to just do a few steps. If you just need, it's better you just follow these steps the next time you're doing an interrupt. The first is you create a base type and you call it check if yield required. So you can just give it any name you want, but the value of this will be either a true or a false from a function called xtask resume from ISR. So the input parameter to this function is going to be the handle of the function of the task function that I have just created. So this is going to be my interrupt task. So I need to check if I need to do an yield, and if I do need to, or if I don't, the result will be at 0 or 1 and stored in this variable called check if yield required. And the next instruction, the next piece of code is to do an yield, and the input parameter is going to be this. So it might get a little confusing, but that's it for every interrupt. So the next time you're doing any interrupt, just make sure that you have these 3 lines. So the only difference is that inside the parameter of this function will be the handle of the task that you want to execute. But the next time you have any interrupt, just follow these steps here. So right now, let's do a recap. I have initialize my button, so that every time I press a button, it will jump and start executing this ISR. But in this ISR, I do not have any actual code that I want to execute, because my real code is this, because this is what I want to do when I have an interrupt. So I will write that in a different task inside an infinite loop where I have the task suspended, and when the interrupt occurs, this task will be resumed. So this is the whole idea here. And there is just one more line of code that I need to add, but this has nothing to do with FreeRTOS, and this has nothing to do with your code. So it's basically just clearing up the interrupt here, the interrupt pin. So it's, if I don't do that, then the CPU will just hang up. So let's go ahead and let's run this program. So it is printing hello world every 1 second. So that's task 1, which is supposed to print hello world every 1 second. And I'm going to press the button on the board. So you see that if I press a button, it just prints hey, you press the button. I hope you can hear me clicking the button on the board, right? So you see, so if there was any other code that you wanted to execute, you could just write them down here. So this is how you execute an interrupt, how you handle the interrupt in FreeRTOS. So it might get a little confusing, but try to run some examples, maybe do an interrupt yourself, and it should be really clear for you as well. Thank you very much for watching.